This is Tanish Vakse, and welcome to the very first episode of NeuraBridge. NeuraBridge here is an initiative built to make complex ideas simple and accessible to young learners everywhere. We are working with government schools and NGOs to share these conversations in both rural and urban classrooms so more students can explore how science connects to real life. The goal is to spark curiosity among young learners and to show them that fields like AI or neuroscience can be used together to make something better out of our lives and the societies. And today, starting here, we have got a new guest who is an artificial intelligence engineer and AI engineer, and a very good friend of mine, Soham Swami. So, hello, Soham. To start off, could you tell our listeners your name and what exactly an AI engineer does?
Hello, everybody. I am Soham, and I'm an engineer who has near around 1 years of experience in the machine learning field. Uh, what was the question again? Sorry.
And what could you tell what exactly an AI engineer does?
That's a very broad umbrella term, to be honest. Various engineers have various different profiles, so there are multiple projects which a company handles, and you are assigned to one of them. So, for example, if somebody is working on autonomous car driving, suppose if that is the project, then you will be working with a lot of real-time image detection and threat detection and stuff like that. So, it really depends on what kind of project you're doing.
Okay, great. And a vast field to be actually talking about. But then getting into it, what first got you interested in artificial intelligence? And was there a moment, a particular moment that you realized, yeah, I think AI is something that I want to study more deeply or professionally?
Yeah, that's a very interesting story. Actually, my degree is in information and communication technology. I'm not an AI engineer by my education. Uh, however, the thing that really interested me in it was the way AI predicted stuff, like it was actually thinking. Like at that point, I didn't know that AI is not really capable of thinking. It's just very high level of pattern recognition. But I was really fascinating. Like, how does this machine answer all of my questions without like, how does this machine have so much knowledge and how is it able to answer questions in every single field available? So yeah, that got me interested in it, and yeah.
Hmm. Yeah, so AI is a very buzzing term in today's world.
Mm-hmm.
The word AI is everywhere, but it often feels mysterious. So, how would you explain AI or artificial intelligence in the simplest possible way? Because this podcast or this series that we are doing could be going to people who are not very used to or familiar with the
Mm-hmm.
term. So, to put it in very decipherable and simple terms, what is AI?
Okay, so before even we begin, let us just make one thing very clear. Like a lot of people have this misunderstanding that AI actually thinks it's in the name, like artificial intelligence. So it might be able to recreate what we have inside of our brains. However, the reality is not so fascinating. To be honest, it is a set of code which basically has a very high and complex level of pattern recognition. So
Okay.
the interesting part about that is a- there are a lot of terms that are thrown around, and you might have heard of something called neural networks. So uh, they were the idea of neural networks actually came from neurons inside of brain. So the researchers wanted to recreate how we think, and they tried to create a system basically, which was in some form able to recreate that which is actually going inside our head. And that is how they came up with the idea of neural networks, and then it started progressing. But yeah, at the end of the day, it is just higher level pattern recognition, not actual
Yeah,
thinking.
that's great. And actually, speaking of the Neura networks that you're talking about, the name
Hmm.
NeuraBridge was quoted from the same concept that was
Oh.
connecting ideas at a broader level. So
Hmm.
Neura didn't have anything or everything to do with neuroscience in particular, though I have my own field of study in the subject. But it
Yeah.
was actually about connecting ideas at that level, maybe
Hmm.
similarly as Neuralink or those terms decipher. So it's
Yeah,
very
that's
nice to be
interesting.
seeing those concepts connect here as a part of the first episode.
Yeah.
Yeah. So coming back to our questions, many people imagine AI as robots or chatbots. but it's
Mhm.
actually in so many parts of our daily life. So could you share
Yeah.
a few examples of AI is already in our daily lives and we interact it at a daily basis?
Uh, the example that I would like to give first is like very, very basic that so that everybody would be able to realize it. And this is also an example that is given to students who are actually learning AI for the first time. So as everybody might know, like whenever you get an email, it is directly classified without you having to interfere into whether it's a promotion or is it a spam or it is a important. So one functionality of AI is actually working behind that, and it is what it is doing is it is going through the content of email and it's looking for the keywords inside that email. So suppose the email says great offer or super discount or something like that. So because of those keywords, the it's a hint for the model and it understands that this might be a spam email. So this is one application which is like on a very, very basic level. Now you just the sky is the limit, to be honest. You keep expanding on this, you keep going ahead and ahead, and then you get very large language models like ChatGPT, which can now generate images, like answer questions, solve mathematical problems. Like it can do everything. So yeah.
Yeah, that's great. And now that we have come to the methodology of AI,
Mhm.
we often hear that AI actually learns from data. So, how do you say that AI learns in a human way? So, does it learn as in, does it learn new concepts, or is it just new sets of codes being added to it and it's just evolving? So, is it learning actively, or is it also a human done process?
It totally depends on what your goal is. So, for example, suppose you want to create something, suppose you want to create an app from
Hmm.
which you just scan from your phone, and it tells you whether the image which is like being captured is it a food item or is it not a food item. So let's start with something very basic. So for that, you would have to train the model on hundreds and hundreds of images of food. Suppose, for example, tomato. So you will have to go through you have to create a data set, and then you have to train your model for it to recognize that this is how tomato looks like. And
Okay.
then after you go through that process, you have to go through uh, error correction, so error handling and stuff like that. So the accuracy of the model is actually good. It's not like identifying onion system. So, so a lot of stuff is going on behind, but the essence of it is what your goal is. So this is one thing. The second thing is, for example, if you're trying to go for something like a prediction model, predictive analysis or something like that. So another one more very basic example that I can recall from my engineering days is like uh, linear regression. So
Okay.
the
Yeah.
most common example is suppose you have a data of a region of houses and you have multiple tables and like in the data set you have information about multiple stuff like how large the house is, how many rooms does the house have, what is the rent of that house. So you have a big data set, and now you want to predict something. Ki, if I have a house in this particular region, if it has 4 rooms, if it is this square meters of area, how much would be the price of this house? So again,
Right.
this is another different type of exam. So it depends on what kind of goal you're trying to achieve, and then you go forward to it. There's no
But it is
such thing as
essentially learning and evolving over time.
yeah.
Yeah,
Oh,
it is
one
developing.
more thing.
Yeah.
That like this is a very important thing that I should mention. There are multiple ways and multiple paths of learning. So linear regression, which we just talked about, it doesn't actually learn continuously. So you create a model once and that's all.
Hmm.
So
Okay.
it won't learn new things. But there is like multiple fields of branches, which are like one of them is called reinforcement. So uh, the way you teach the model in reinforcement learning is it has a reward versus punishment kind of model. So when
Okay.
the model actually predicts something correctly or does the result is proper and good and accurate, then it is rewarded by some kind of tokens or something like that, whatever you are assigning to that model. But if
Mhm.
it makes an error, then it is kind of punish, not really punish, but
Okay,
the
but it's
model
a
is,
negative
yeah,
reflex or
yeah.
something.
So in those kinds of model, it can
Okay,
actually handle data immediately. So it doesn't need a fixed set of database. It can learn
okay.
as we go. Yeah.
And it can take decisions for itself as well
Yeah, yeah.
in that time
Obviously,
span.
you need
Okay.
to make it in such a way that the accuracy is high, but essentially, yes.
But so it is an independent model if we go the way it's working right now. So it does take decision for itself sometimes, even without proper code intervention.
I think you would need intervention only in the initial stages. Once it
Okay.
gets to a level where it can
Mhm.
perform without errors, yeah, then it's fine.
Okay. Okay. So, how do you think AI or artificial intelligence can be used in fields outside of this? So, AI is a thing we see it being used for plagiarism or being used in essays or drafting things in unethical ways to get it posted. But
Hmm.
what other than that? Say, I have done my study in neuroscience where I connect AI into predictive modeling and I
Hmm.
predict some neurogenetical, neurodegenerative diseases at a very early stage through blood scans and other things. So that is for Alzheimer's, Parkinson's that I'm doing it. And it is at a very early stage, but it is about predictive modeling where we can predict a person's diseases, say 20 or 30 years in advance. So, how do you think things like these can be better evolved and maybe used in other fields other than neuroscience or medicine?
There are actually a lot of fields where AI is
Okay.
intensively used. However, we just don't realize it. So,
Okay.
one of the first projects that I did was crop leaf disease detection. So
Okay.
we know, so see, the way it works is you have a broad concept and then it gets broken down into what your application is. So the main
Right.
idea behind uh, my project was image detection. And image detection can be
Okay.
used for any, like the example of tomatoes, which we gave, the food
Right.
detection thing.
Yeah.
But it is not really useful. Like, where are you using it? But here in crop leaf disease detection, what it did was we had you just feed, for example, a farmer just clicks a photo on his phone
Mhm.
and he
Yeah.
uploads the photo to the app or whatever model you have. So he doesn't have to do anything. He just have to click the photo of the leaf and you just have to upload it. That's all. The model will work behind the scenes. It will detect what kind of disease does the leaf have. Is it healthy or it is not healthy? So all the classification will be done by the model. However, the difficulty is implementing these kinds of projects in real life because you would require, especially in the medical field, which we are talking about, you can't take risks. So, for
Right.
example, if you are working with something, brain tumor detection or something like that, so these are
Right.
life-threatening diseases. So you have to be
Absolutely.
very,
Yeah.
very sure when you're ruling out these kinds of models. And that is one of the
Right.
biggest difficulties, I would say.
Mhm. But coming, as you said, it can be very dangerous because we are essentially dealing with lives and
Hmm.
errors or lapse in judgment in these models could eventually lead to loss in lives or further complications rather than the disease. So, coming into all of this, do you think it should be used in medicine in the way that it's being done now, in ethical ways, in ways that AI is evolving? Maybe it could lead into other complications such as misrepresentation of patients, could be loss of privacy, data, could also
Hmm.
be lapse in judgment by the models.
Hmm.
And then noble jobs like doctors or people that are actively working in healthcare could be moved aside in a way. So, talking about the more broader application and concerns about application of AI into these fields.
So my answer to that question is like a 100% yes, because
Okay.
the way we have to change the way which we are trying to approach AI. Let us try to understand first that we are not trying to seek replacement for doctors. That is, I feel that is
Mhm.
a very pessimistic way of thinking.
Okay.
However, we should think in a way that we create tools which help the medical personnel to make their life easier, basically. So,
Okay.
uh, like you described, the early detection models, which can detect diseases far earlier than it is possible, and
Right.
actually at much cheaper rate as well. So
Yeah.
we have to think in these ways so that we
Mhm.
actually help the medical person. It's not a
Okay.
question of whether uh, it is helpful or not. It is a question of how
So
we
I
are
think
implementing.
it's more about helping the people who are already in the field to do their jobs more efficiently and accurately,
Correct.
helping
Correct. Yeah.
them have better judgment, because even doctors go wrong in
Correct.
some places.
Yeah.
It can be human error, it can be judgment, it can be lapse in anything. So I
Correct.
think
And
having these technologies there and
mhm.
having a good mixture between these technologies can actually help people that are in the job to do their jobs more better and efficiently.
Yeah. And
Yeah.
why not? Like it's very clever actually because uh you the in some fields where you would actually would have to spend a lot of time over analyzing things and going through all the images and stuff. Here you have a model which can go through it in within seconds. So
Right.
like underestimating it is not really the answer.
Mhm. Okay. So now, because this is for young learners and they could be concerned about ethical or privacy concerns that everybody has with AI today. So AI systems often learn from data, but data can be biased as well. So how do AI engineers or people in this field make sure that the machines that we build make fair, ethical, and equal decisions for everybody in each case? So does the machine also have preferences towards something?
Yes, most definitely.
Okay.
It totally depends on how it is designed and how the data set is.
Mhm.
Um, Let me give you an example. Suppose you're conducting, since we're talking about medicals, let me think of a medical example.
Yeah.
Suppose if we are trying to work something related to hemoglobin or something like that,
Okay.
and
Yeah.
let's say the normal range for males is something like 13 to 17, correct? If I'm not wrong.
I think 13 is the range that they 15,
Yeah,
13.
so
Let's not
13
go
is
on
the
the
min.
numbers. Yeah. Yeah.
Yeah, okay. So let's assume it's
Yeah. Yeah.
between
Yeah.
13
A
to
normal
17.
range.
Okay.
Mhm.
Yeah. So a very important thing is to clean the data and make sure that you don't have outliers. So, for
Mhm.
example, there's a person who has a hemoglobin, for example, let's take he has a hemoglobin of 25. So
Okay.
now this singular data point is going to affect your entire model, and that is
Right.
going to skew the entire data towards that 25. That is not
Right.
going to
That's an
work.
extreme level. Yeah.
Yeah, so that is why we have something called pre-processing of data, which is
Okay.
like the crux of machine learning. All
Mhm.
this talk about choosing which kind of model, what kind of training, and this comes later in the stages. Like I would say 80% of what you do is basically focused on pre-processing, making sure there are no inconsistencies in the data, everything is very clean, and basically it doesn't have something that would basically like skew your whole entire risk. So pre-processing is a very important thing. And once you do that, once you have cleaned, once you have filled, there's a lot of cases as well where you just the data is missing. You can't do anything
Mhm.
about it. So
Right.
you have to find ways to tackle that. But
Okay.
to be honest, if your data is bad, the way you said that if it is biased inheritance, you can't really do
Mhm.
much about that. The
Okay.
solution is to find better data because that is your raw material. That is like the foundation of your building. That is
Okay. So it's
what
to
is what.
have more balanced raw data that we feed while actually developing the engine
Yeah,
and then trying
yeah,
to
yeah,
get
yeah.
it through inconsistent cases as we have in real life.
We
Okay.
have methods, we have techniques, but there's
Mhm.
only so much you can do about bad data.
Yeah, that's there. That's a part of how we evolve with technology, right?
Yeah,
Not
yeah,
the first plane was very perfect, but now we've got Boeings, which have almost no chance of going crashing. So I think that's how we evolve with technology, especially in such early stages. So
yeah.
now coming for guidance for young learners, because we have spoken a lot about ethical concerns and how AI can be used into cross connectional fields and how methodology of AI works. I would like you to share for students listening right now how might many might not have proper access to AI. So any labs, resources, or places that you have where people can learn more about AI and have hands-on experience as children or as young learners trying to just explore the field and maybe make something out of it.
That's a great question, actually. There are
Yeah.
so many sources. Uh, YouTube is one of the biggest data repositories for anything, to be honest. So
Okay.
the biggest thing, or for the, I would say the toughest part about learning about anything is curiosity. If you have curiosity, you can find almost everything on YouTube. There are very good
That's
channels.
true. That's
Like
true. Yeah.
uh, there's a if I recall it correctly, there's a really good channel called Data Quest, which
Okay.
which exactly what we're discussing. This person explains very, very complex machine learning terms in very simple languages to people who have no engineering background at all. So
Okay.
even in my engineering days, I used to go there, and like even by learning the concept, it was better than like reading books and stuff like that.
Mhm.
Like so, yeah, there are multiple resources. There are also courses on Coursera which are very beginner level courses offered by very high level researchers, and these are made in such a way that they are broken down into simpler terms so that laymen can understand these terms and actually be interested. And then once you get into the field, I think the best way is not to consume a lot of knowledge, rather than it is better to produce. So start with the simple projects. The it is similar to like once the way which we start learning coding. So the very
Right.
first code that you write is like identify
Hello
if
world,
this, yeah,
HTML or
hello world.
something.
If
Yeah. Yeah.
identify
That's
if
right.
this given number is even. So you're trying to
Mhm.
build the
Mhm.
logic. So if
Okay.
so, yeah, same thing. You have very basic projects that you can do. So I guess start
Mhm.
with that.
Yeah. Okay, yeah, it was a very insightful session altogether. And to have as a last, not a question, but just an
Mhm.
input from yourself. So, uh, if you could leave every student here with one thought about the future of intelligence, whether human or artificial, what would it be in your case or your experiences through being an AI engineer and
Mhm.
being also a young learner?
Okay, yeah. So I think the younger generations are scared of AI, to be honest,
Okay,
because
yeah, in a way,
uh,
yeah,
yeah, in
it's
a way,
also
yeah,
seen as
because
a more negative thing,
Mhm.
not to optimize it,
because
but then seeing it as a thing that is, uh, I think, making people lazy or making people less authentic in a way.
yeah, and in
Yeah.
terms of careers and jobs as well, because you
Mm.
always hear that AI is going to take your job, like yeah. So I think the way to approach this is not to be so pessimistic about it.
Okay.
We have to understand that at the end of the day, it is a tool and very high functioning tool.
Mm.
So in future, what I would like to leave the listeners or the students with is like make sure you understand the concepts that are being taught, especially not
Okay.
in just AI, but whatever field they are trying.
Right.
Because the easy work or just the what do you call the grunt work is
Hmm.
going to be
Okay.
done by AI. It's
Right.
in future they're not going to be. It's like all the work that is the grunt work it would be done in seconds. So what would be
So it's
appreciable?
to actually have a calling for ourselves and to do things that only we can do in a particular way.
Yeah, and whatever
That
subject you're
makes
trying
us
to,
irreplaceable in a way, something that AI cannot do.
yeah, whatever
Yeah.
subject that you're trying to go ahead with, make sure you go very deep into it and understand what are
Hmm.
the concepts behind the modalities of these subjects, not just go surface, take the surface level and just know how to apply tools or something like that. Go actually deeper.
Okay.
How is this model working? What are its advantages, disadvantages? Critical thinking, basically.
Thank you so much, Soham. That was an incredible discussion. Thank you for taking the time to helping us understand how AI connects to how we think and learn. And to everyone listening, remember that curiosity is your greatest bridge. Keep asking, keep exploring, and keep learning. This is NeuraBridge. I am Tanish Wagse, and we will see you in the next episode with a new topic, a new way of connecting ideas together, and to learning more. Thank you.